So we can also find the general composition using two functions algebraically. So for example, given f of x equals x squared minus 1 and g of x equals x over 1 minus x, write the composition function f of g of x and state the domain and range. So f of g of x, that means we're going to plug g of x, the entire function of g of x, into f of x. So we're going to replace, instead of x, we're going to replace it with x over 1 minus x. What this really means, as I said, we're going to replace each x with x over 1 minus x. So that means instead of x squared, we're now going to take x over 1 minus x and square that whole thing minus 1. Now we're also asked to find the domain and range. The domain, all possible x values, and in this case we have a denominator here, and we don't want our denominator to be equal to 0, so x cannot be equal to 1 because that would make our denominator equal to 0. Range. This one uses a rule that we haven't looked at since last semester. This fraction here, you're going to have a range on there. You can have an asymptote kind of down below. Using your leading coefficients of the top and the bottom, you're going to take y equals the leading coefficient of the top over the leading coefficient of the bottom, which is actually -1 because technically if we were to write this in standard form, that would be our first term. So it's 1 over -1 giving us y over, just -1. So we're going to have our y values greater than that asymptote of -1. It's going to get down that far but never quite touch it.